Hello, fellow apprentices and Sparkies. Today's topic is a brief understanding of relay logic. Imagine how your factory was controlled before them big upgrades. This factory was a series of simple, reliable devices that control the plant. That is the power of relay logic. And what about relay logic today? Relay logic is fundamental to industrial automation. It is the bridge between manual switches and automated control. So later on, we'll also talk and explain about what relay logic is and how it works and the applications why it's still important till this day. And I'll be reviewing some simple symbols and some basic diagrams as a start. Let's start off with some simple relay logic. What is relay logic? Relay logic uses electromechanical relays and switches to build and connect control circuits. It enables processes such as starting and stopping motors and using of safe interlock systems such as e-stops and regular stops. An example is this hard-wired litter. This litter uses simple relay logic for a conveyor system, and the conveyor system brings in a box and brings it to the elevator. After that, it raises a box to retrieve a lid, which gets folded onto. This litter with controls and switches to use helps manufacturing lines and uses many relays for reliable operations. And we'll be looking at a simple diagram of the start and stop circuit here. Alright. Here are some of the basic parts and symbols of relay logic for this cabinet. This cabinet is hardwired compared to another litter that is the exact machine, but the other litter has an upgrade with a PLC. And I'll show you some symbols and some parts in this cabinet. Alright, this right here is a disconnect. It matches up with the diagram that is here. This right here is a motor starter, and we'll look at the diagram and find out where it is too. And as you can see, all these relays here are all interlocked. The reason why it's interlocked is so that some equipment cannot be energized both ways, such as forward and reverse, up and down cannot be energized at the same time. And here are some timing relays, and there is also a clutch and a brake relay down here. And I'll show you guys some symbols and what they mean on the diagram. Let's take a look at this diagram for that litter, as it is hardwired, and this is the relay logic for it. And I'll be explaining some of these symbols. Starting off with the disconnect. This is a symbol for a disconnect. And it comes down to the circuit breakers. After the circuit breakers, it leads down to the motors. So on, as you can see, these symbols right here stands for the overloads. And coming back over here, circuit breakers and overloads also come to a transformer. And here are some more basic symbols. This right here is a fuse. And as the fuse, it's hard to see, but this is a selector switch for on and off. Coming down, we have a temperature sensor with the e-stops in series. The symbol right here is a normally open push button. And as you can see, these outputs over here with the lines coming out are pilot lights. And the symbol right here with the gap stands for normally open contact. The symbol right here, different from the one right here, this is attached as a normally closed push button. For this symbol right here, it stands for normally closed contact. As you can see, there is no gap and there's a line going through it, stating it is a normally closed contact, compared to the open gap one, which is a normally open contact. Furthermore, with these symbols, this right here stands for a coil contact. Leading on to some more contacts on this side. What else can we find? Here we see some normally open and normally closed limit switches. As you can see here, it is not touching. So this stands for normally open limit switch. The one down here is contacted. So it is a normally closed limit switch contact. And as you can see over here with this zigzag line, I will explain it, is for a solenoid. And this right here is a basic diagram of relay logic that is hardwired. Furthermore, it is important to remember some of these symbols. Although it's a simple relay logic, these symbols play an important role into how the ladder works. Let's take a look at this ladder that's over here. It performs the same exactly as the other one that we just viewed. So as you can see in this cabinet, it has a PLC that controls the interlocks and has a program. And as you can also see, it gets rid of the majority of the relays. So how does relay logic work in practical systems? These relays respond to small electrical signals for opening and closing contacts that can control the larger loads. Although one is hardwired and one has a PLC, both are still wired and programmed to do the same job. And when we upgraded this ladder over here to a PLC, it is nice, but you still need to have the essential knowledge of relay logic before you can start programming. And why is that? Because relay logic forms the foundation for modern PLC programming and industrial safety systems. Many emergency stop and interlock systems still rely on relay logic for fail-safe operations until this day. So such as this example in this print, you can see that the wires are wired in series. Here is some more information about relay logic and the relations to PLCs. As I said before about relay logic to PLCs, it's the transition to digital systems. Basic relay logic diagrams are directly mapped into PLC ladder logic. It eases the workload for technicians to build logic, and it helps troubleshoot for less downtime. Even as digital PLCs become more widespread, including the big upgrades you wish your plants had, understanding relay logic remains essential for troubleshooting. Like back to square one of where the power starts, and you start tracing so on to the root of the problem. Here I will show you an example of the two ladders. How relay logic is transitioned to ladder logic on the program. Okay, here is the relay logic wiring for the hardwired ladder. Here you can see the start button. It energizes the machine pilot light on. And it also energizes the control relay to hold in the contacts so it stays energized when the button is released. And transitioning over here, you can see that it does the same exact thing in the program. The start button turns on the machine pilot light on, and a control bit to hold the light on, and other electrical components that will need the bit to use on for. As you can also see, the symbols are similar to those on the diagram. An amazing transformation from relay logic to PLC ladder logic. Another advantage of knowing and using relay logic is that it's being cost effective. With some simple equipment, it is more cost efficient with a small relay circuit versus installing a small PLC. An example would be the simple conveyor. All it does, it starts and stops. So instead of having a small PLC to interlock and handle multiple inputs of off and on buttons on each side, the small relay logic is the more cost-efficient choice. It is also simple enough to troubleshoot with no prints. As simple as this is, having prints is still helpful for troubleshooting, and is a must they should have nearby. I understand prints or diagrams don't always match up to what is wired. That is also why you should learn and know relay logic, so you can be more efficient with the downtime and you can build the future. Here's another example that I'm working on, turning relay logic to ladder logic for the future. To do this, I must understand how relay logic worked. Originally, all these buttons are interlocked through hard wiring through some relays with many normally open contacts and normally closed contacts. This is part 2 of the progress. And this is the final. With this upgrade, it is to be more effective in use and for troubleshooting. As you can also see, it has less clutter of wiring. Also partially to be safer with 24 volts DC than having 120 volts AC. And a side lesson is when you see yellow wiring, it means foreign or external power. So still be careful, knowing that although the blue 24 volts DC is off, the yellow wire can still potentially be live. Alright, shutdown time, no overtime. There's a lot more to relay logic as to learning what each equipment does and how to use the right symbols to build your circuit. But in conclusion for this brief information on some basic relay logic, remember, relay logic is the root of modern automation, underpinning both safety and reliability in countless processes. To program the future, you must understand the past, and relay logic is where control began. I want to thank you for your time, and I hope this information can help you with relay logic and the future it has. Alright, peace out.